A is just like grade 10. So look, my first one is an x squared, my last one is minus 24. The only way to get an x squared, x and x. 24 has some options, 1 and 24, 4 and 6, 8 and 3, 12 and 2. We need the outside and the inside to give us 5. So if you go through the options, I'm pretty sure 1 and 24 is going to be not so good. 12 and 2, that never makes 5. 4 and 6, 8 and 3, yes. 8 and 3 would make 5 if you could subtract, so let's try. So I put the 8 and 3, I need a plus 5, so that means I would like to have plus 8 minus 3. That gives me plus 5. Double check, does your last one still work? Yes. Perfect. Now, there are two options for B. Both work, but one can often be a lot more work. So, the longer method, which is if I gave you this question right now and I asked you to simplify and factor, you would probably choose the longer method. And the longer method would mean you distribute here, you FOIL this out, you combine all your like terms, and then factor in the end. But I'm going to show you the shortcut first. And for the shortcut, you get to pick any letter you want other than X, because X is already used. So Audrey, pick a letter. What letter would you like to use? A. Oh, good choice. So what we do is we say, hey, I know how to factor, right? I know how to factor when it's something squared and then it's a number times that. That's a trinomial, right? In B, the key to B is recognizing, hey, I have something squared and then that's something again. It's the same idea as A, but this time the something looks not as nice to factor. So what we do is we pick a letter and we decided A, and we say, well, let's temporarily just make A equal to x minus 6. Because then I could rewrite this, and instead of x minus 6 squared, you see that you would have A squared. And instead of 10 times x minus 6, you'd have plus 10 times A. And then you'd still have the minus 48. And this looks like grade 10 factoring. So we just say, well, it looks like grade 10 factoring. I bet you I can factor it. Notice the common factor of 2. Take that out first. And then we still have the A squared part here. Here's your first one. Here's your last one. Only way to get A squared would be A and A. Anybody noticing anything interesting happening in this factoring right now? Compared to what we did in part A? Do you see that it's the same? A squared plus 5A minus 24. I mean, it's got X, and this has got A. But it is so I was going to figure it out, but I'm like, well, I could just cheat because I already did that in part A and factor it. So now we factored it with A, but we let A equal x minus 6. So our last step now is we have to substitute back to x's. So I still have the 2. I like using big brackets and little brackets. So now where the A is, I can substitute back because I made A equal to x minus 6. I can substitute that x minus 6 back. Put it in brackets when you substitute. Can I simplify this? X minus 6 plus 8 will be x plus 2. X minus 6 minus 3 will be x minus 9. Still a fair bit of work. This is the shortcut. Okay. The other option actually to multiply it all out. So we had, here's the original question. Double check that I remembered it correctly. Yes. So option 2 is you have to multiply everything out. Remember that squaring is foiling. So if you did all that FOIL, you would get x squared minus 12x plus 36. Here I'm going to distribute plus 10x minus 60 minus 48. This 2 would need to get distributed as well. That will give me 2x squared. I'm going to have a minus 24x and then a plus 10x will give me minus 14x. And I'm going to have 72 minus 60, give me 12, minus 48, negative 36. This has a common factor of 2. First one's x, so it has to be x and x. 18. 1 and 18, 9 and 2, 3 and 6. Which one gives you 7? 9 and 2. I would need the 9 to be negative, the 2 to be positive, and notice. If we could see that. Those are the same with both methods. Okay? But here you would have to multiply everything out and then factor. It ended up that method 2 wasn't too bad. Sometimes method 2 can be extremely difficult, as we'll see in part. Like, if you tried method 2 for part B, if you didn't get completely stuck, I would guess you would be at least stuck for somewhere between 30 minutes and an hour. That's how hard I would say B is using option 2. So let's look at B and I'll explain why option 2 isn't the greatest for this one, but we have 3, 2x plus 5 squared plus 10, 2x plus 5. All right. Audrey picked last time. I'm not going to let Allie pick for similar reasons. Nico, pick a letter you'd like to use. R. Ooh. So let R equal. So how do we know when we want to use this substitution thing? Well, first of all, the same thing has to happen in both places. We have that 2x plus 5. Then when I put it in, now I have 3r squared plus 10r minus 8. No common factor here, but my first one is a 3r squared. My last one is a minus 8. Well, 3r squared, only one option, 3r and r. 8 could be 1 and 8 or 8 and 1. 2 and 4 or 4 and 2. Do you see anything that makes the 10 with the outside and the inside? I sometimes start with the 8 and the 1 because I feel like the mental math might be easier. Can you see if you put the 8 on the outside here, you get 24. That's going to be bad. And then I put the 8 here on the inside. 8 and 3, does that make 10? Only if you make mistakes. No, it's close, but not quite. So it's probably going to be 2 and 4. Ooh, this is interesting. This is really interesting because it could be 2 and 4 or it could be 4 and 2. If I do the 2 and the 4, I get 12 and 2. Does that make 10? Yes, if you're subtracting. If I do the 4 and the 2, does that make 10? Well, that would give me 6 and 4. That makes 10 as well. Oh my goodness. How do we know which one? Well, this is where you have to check. So option 1, you could pick one and check. And if you pick the wrong one, it won't work. Option 2, this sign here has a minus. That's telling you you're going to have to subtract instead of add. So it's going to be the 4 and the 2. 12 minus 2, so I have plus. Because that way, with the minus, you still get your last one be negative. If you added, your last one would be positive. And now we have to substitute back, so that this makes me happy, because this is one of the hardest ones, harder, trickier ones, because you have a possibility of picking one that seems to work, but doesn't. That's why it's really important to check in the end. But now when we substitute back, my big brackets, I'm substituting, what did we make r? 2x plus 5? Yeah. So I substitute 2x, oops. 3 times 2x plus 5 minus 2, and 2x plus 5 plus 4. If I simplify this, I'm going to get 6x, 15 minus 2 minus plus 13. And here I'm going to get 2x plus 9. If you used method 2 and multiplied everything out and combined all your like terms, you would have gotten, and I'll just multiply this out, 12x squared. My outside is 54 and 26. And 13 times 9, you would have gotten this. And this is where I said you would be stuck for 30 minutes to an hour. That is hard to factor, because 12 has like 4 options for 12. 117, I don't know how many of you have your 13 times table memorized, but most likely if you saw 117, it would not scream 9 times 13 to you right away, right?
Désolé de vous déranger. Courte annonce pour les membres de l'équipe d'improvisation. Vous êtes priés de vous rendre dans la classe de Monsieur Dufour, 2D4.
If you use the sum and product strategy,
Merci.
your job would be to find two numbers whose sum is 80 and product is 1,404. I'm telling you, that is not even good. Trying to find those two numbers with that supposedly better strategy would suck as well. So this is a great one where I would not even recommend method 2. Circle questions 15 and 16.